In this answers tutorial video, we will be looking at Lab 2 question number 2. Before we get started, we first have to determine which units we're going to use throughout the question. And looking at our model, our best option would be to use the SI column of the table of consistent units. So we just have to convert all of our centimeter values to meters and gigapascals to pascals. Next, we can go ahead and determine what element type we will use in this question. Our best bet for this model would be to use a solid element type with an axis symmetric function defined. Basically, what axis symmetric will do is it will revolve your model around the y-axis. So looking at our model here, we can see that it's perfectly symmetrical about the y-axis. So with axis symmetric enabled, we can simply model a plane here that goes from the y-axis to the outer edge, and ANSYS will revolve that around the y-axis for us and solve it accordingly. Next, we can go ahead and define our material properties, which in this case we were given elastic modulus as well as Poisson's ratio. When it comes down to actually creating the model, since axis symmetric is selected, we only have to model a half of the actual object. So in this case, I chose to model just the right half here. And another thing I noticed is it's also perfectly symmetric about the middle of the object. So just to save computational time, we can split up the object in half like so and model just this rectangle right here. In terms of meshing, no mesh size is specified in this question, so we can pick any value that we want. So I'm just going to choose to pick an arbitrary value of 0.001 meters, just because I think it will best suit this model, but the choice is up to you. Next, in terms of constraints, since we are splitting the object in half along this axis right here, we're going to have to put a symmetry body constraint. And notice how we don't have to specify any constraint for the axis symmetric function that we defined. It just automatically knows that this is being revolved around. Finally, we can specify our loads, which in this case is just a point force located right at the top here. So we can go ahead and open up ANSYS. And our first step is to define the element type. So preprocessor, element type, add, edit, delete. And we're just going to select on the solid. And make sure you select the 8 node 183 right here. Click OK. And we're going to go into options and define the axis symmetric, which can be found under K3 right here. Click OK. And we're going to close that down. Next, we're going to enter in the material properties. So material models, and we're just going to enter in 68.9 gigapascals and our Poisson ratio 0.35. Okay, and we can close that down. Now we can go ahead and create our model. To do that, modeling, create areas, rectangle by 2 corners. And since we are splitting it up, we're just modeling that top right portion of it right here. We're gonna say it starts at the origin, this rectangle, and it has a width of 0.01 meters and a height of 0.025. All right. So that's all there is to modeling it. Now we can go ahead and mesh it. Open up the mesh tab here, mesh tools, and we're going to select on element attributes. We're going to select areas, click set, click on the area, OK. And all of this information here is what we want to give to this rectangle. Click OK. And here are under size controls, we're going to select on the area one. And it just asks us for the element edge length. And this is up to you guys for the question. I'm just choosing this value because I I think it'll fit the model nicely, but once again, it's up to you guys on how accurate you want your model to be. Okay. And we're just going to click on mesh. And there we go. Next, we can go ahead and apply our constraints. So we can close down the preprocessor tab, open up solutions, define loads, apply structural displacement on symmetry BC right here, and on lines. And we know that since this is being repeated once again down here, so it's symmetrical about this line, so we're going to select on the bottom line here, click OK. And that's all the body constraints that we have, because once again, ANSYS knows that this is being revolved around because we selected the axisymmetric function. So we can close that down. And we can go ahead and apply a load this time. So we're going to click on the force moment here under structural and click on nodes. And we're just going to select the top node right here. Click OK. And we want this force to be in the y-axis. And we want it to be 500 newtons. And since it's positive, it'll point upwards. So this is good. Click OK. And notice here how a red arrow should appear in the top right corner. So we can go ahead and solve our model. We can close down the define loads and click on solve current LS. Okay. And our solution is done. So we can go ahead and extract our data. Looking at the question they gave us, first they ask us to show all of our boundary conditions, so body constraints. And to do that, we're just going to go under plot controls here, symbols, and make sure all applied BCs is selected. Click OK. And if these arrows weren't already on the screen, they should now appear. The next two questions, they ask us to basically show all the stress values on the different nodes, and you guys will have to do some hand calculations with them. But basically, what I want to show you guys is if you open up General Post-Proc, list results, nodal solutions, click on stress, and then Von stresses, click OK. Here will give us a table of all the nodes in this model, so all 300, 400, 500 of them. And so each node point, it'll give you the exact stresses in X, Y, and Z axis. But the problem here is, well, when you guys do your hand calculations, you only care about a certain portion of them, right? So to fix this, we can go ahead and go under select entities, and this menu should now appear. We're going to select nodes by location, y coordinates, and we're going to enter in 0 to 0.002, and then we're going to click OK. And if we were to go back into nodal solutions and open up that chart again, now only the nodes that were in that range that I put, 0 to 0.002, all those nodes that appear in that range will now appear in this chart. So that's just a way of saving you guys some effort of trying to find, going through that chart before of all those 700 nodes, and instead you can just go through this chart and it'll give you all the nodes in that area. And if you want to see exactly where node 314 is, let's say, you can click on plot, key points, plot, nodes, and then so it'll display all the nodes here in your model. And if you go under plot controls, numbering, no numbers, if you select it on, it'll give you all the known numbers in your model.